Hello. Today we'd like to talk to you about some of the recent innovations with heat pumps. A heat pump is a device that uses mechanical work to move heat from one location to another. It does this using the vapor compression cycle, the same principle that makes your refrigerator or air conditioner work. In fact, a heat pump is basically an air conditioner that can work in reverse. In the winter, it can extract heat from the outside air or ground and move it inside. And in the summer, it extracts heat from inside air and moves it outside or into the ground. There are two common types of heat pumps used for space heating. Air source, shown on the left, which extract heat from the air, and ground source, shown on the right, and also commonly referred to as geothermal heating, which extract heat from the ground. Heat pumps can also use a body of water, such as a lake or pond, instead of the outside air or ground. You probably guessed it, but just like an air conditioner or a refrigerator, a heat pump requires electricity to operate. One of the key benefits of a heat pump is its efficiency. Because heat pumps move heat rather than creating it, they are more energy efficient than standard electrical resistance heaters, able to achieve efficiencies of well over 100%. With air source heat pumps, the efficiency fluctuates depending on outdoor air temperature and decreases as temperature decreases. With ground source heat pumps, the efficiency is more consistent because the ground temperature is relatively stable. If you currently heat with electric baseboards or an electric furnace, switching to a heat pump could result in savings on your energy bill. Heat pumps also have some disadvantages. They are more expensive than some other options, such as a natural gas furnace, both to operate and install. Air source heat pumps can be a couple $1,000s more to install, while a ground source heat pump can be tens of thousands of dollars more to install. Air source heat pumps also have the disadvantage of losing efficiency in cold temperatures. Conventional heat pumps can't extract enough heat from the air to heat a home when the temperature is below -10 Celsius and require an auxiliary heat source. Newer cold climate heat pumps can extract heat down to -25 Celsius, but still require an auxiliary heat source. Ground source heat pumps don't suffer from this limitation. The first heat pump for space heating was installed in 1937. The concept has undergone incremental improvement over the last 80 years. The latest key innovation came in 2001 when the first variable capacity heat pump was introduced to North America. This was achieved through inverter-driven compressors that can vary their operating speed to optimize system pressure and refrigerant flow based on current environmental conditions and therefore achieve higher efficiency. Other recent innovations are better refrigerants that can extract more heat at colder temperatures, and electronic thermal expansion valves that, like variable speed compressors, allow the system to optimize pressure and flow based on the environmental conditions. We estimate that heat pumps are approximately halfway up the S curve. Climate change has created renewed interest in heat pumps, and we expect this to further drive innovation and adoption. A key area of focus for further innovation is improving efficiency in cold climates. Heat pumps can help combat climate change by replacing fuel burning appliances such as natural gas, heating oil, and wood. The impact is highest when switching from a greenhouse gas emitting fuel to a heat pump where the electric utility generates electricity using non-greenhouse gas emitting methods such as hydropower, wind, solar, and nuclear. Even if the utility burns coal or natural gas to create electricity, there is still a greenhouse gas emission reduction by switching to a heat pump, albeit not as much. Heat pumps can contribute to global warming as well. Some refrigerants are potent greenhouse gases, many hundreds of times more so than carbon dioxide. Generally, the refrigerant is confined to the closed loop of the heat pump system, and this isn't an issue, but care must be taken during maintenance and disposal of the refrigerant. This presents another opportunity for innovation as governments and industry continue to research new refrigerants that have lower global warming potential. The renewed interest in this technology presents several opportunities for incumbents and new entrants to this market. We've already mentioned some of them, but let's recap them here. The first is improving cold weather performance. While strides have been made, innovations that allow heat pumps to work better in cold climates are the key to unlocking the next wave of growth. Second is better refrigerants that perform better in cold climates and have a lower global warming potential. Next is improving energy efficiency. As shown in the chart on the right, which compares the cost of heating a residence using various means in Manitoba, a high efficiency natural gas furnace is only slightly more expensive than a ground source heat pump to operate and considerably cheaper to install. Even an air source heat pump is more expensive to operate in Manitoba. Innovations that further improve the efficiency and therefore reduce the operating costs will help heat pumps displace natural gas as a heating source. Reducing production and installation costs can also improve the affordability and economics of heat pumps. Just like operating costs, an innovation that results in a marked reduction in production or installation costs will unlock a new wave of demand for these systems. Another interesting innovative concept is that of shared loops. These work by interconnecting groups of homes and sharing in the heating and cooling load. They are best suited for situations where one or more nodes on the loop is a contributor of heat to the system. A simple example is a data center, which generates significant quantities of heat and requires constant cooling, even in the winter. The heat it produces that would otherwise be wasted can be put into the loop and used by other nodes, such as homes, that are consumers of heat. The technology isn't economical yet, but the concept may be just one breakthrough innovation away from unlocking a new wave of growth. Thank you for watching. We hope that you found this video informative.